Welcome to Tech with Koushik. This is set 1 of our AI-103 Microsoft Certified AI Engineer Associate Practice Question Series. Choose your answer before the timer ends. Then review the correct answer, detailed explanation, and exam tip. Keep track of your score and see how exam ready you are. Each practice set is completely standalone, so you can start here without watching any of the other sets first. Playlist link is in the description. Let us begin set 1. Now consider question number 1. This one tests your understanding of model deployment policy. Scenario: Fabricom operates a travel assistance agent from a Microsoft Foundry project in France. Customer prompts and model processing must remain within the European Union. Traffic varies sharply by season, so the deployment must scale on demand without reserved throughput. The team also requires the deployed model version to stay unchanged until they deliberately replace it. Complete the deployment configuration. Statement 1. Set the deployment type to the blank. Select from 1. Standard, or global provisioned. Statement 2. Set the model version update policy to the blank. Select from 2. Once the current version expires, opt out of automatic model version upgrades, or upgrade when a new default version is available. The answer to the first statement is standard. Standard is a pay-as-you-go regional deployment that can scale without reserved provision throughput and keeps processing in the selected Azure geography/region rather than using global routing. The answer to the second statement is opt out of automatic model version upgrades. Opting out prevents automatic version changes. The deployment remains on the selected version until an explicit change is made or lifecycle retirement requires action. Remember this distinction for the exam. Separate deployment capacity/routing from model lifecycle policy. Standard controls regional pay-as-you-go inference. No auto-upgrade controls version stability. We will now analyze question number 2. Background. Northwind builds a product support agent in Microsoft Foundry. The agent grounds answers in PDF manuals stored in Azure Blob Storage. Current environment. Some manuals contain screenshots with embedded text. The ingestion pipeline extracts that text and supplies it to the agent as grounding context. Business requirements. The agent must answer only from approved product material and must not follow instructions injected through retrieved content. Technical requirements. A security control must detect indirect prompt injection instructions that may be embedded in retrieved documents or image-derived text. Which control should you configure? Now examine the possible answers. Choice A, violence content filtering. Choice B, prompt shields for document attacks. Choice C, self-harm content filtering. Choice D, PI detection. The appropriate choice is option B, prompt shields for document attacks. Here is the technical justification. Prompt shields for document attacks are designed to detect indirect prompt injection in external or grounded content, including malicious instructions embedded in content supplied to an LLM. A. Violence filtering classifies harmful violence content. It does not detect indirect prompt injection. C. Self-harm filtering addresses a harm category, not adversarial instructions, in retrieved content. D. PI detection helps identify sensitive personal data, but does not detect document-based prompt injection. Keep this examination point in mind. Use prompt shields for adversarial user/document instructions. Use content filters or PI controls for different risk classes. Question number 3. Review the situation. AdventureWorks is creating 4 agents in one Microsoft Foundry project. Every agent must query the same Azure AI search service, and the engineering team wants one centrally managed place for the search endpoint and authentication configuration. What should you configure in the Foundry project? The options are: Choice A, a managed private endpoint for each agent. Choice B, a project connection to the Azure AI search resource. Choice C, a separate search access key in every agent definition. Choice D, a new Azure AI search resource for each agent. In this case, select option B, a project connection to the Azure AI search resource. The reasoning is as follows. A project connection centralizes the Azure AI search endpoint and authentication details so multiple agents in the same project can reuse the configuration. The alternatives can be eliminated because A. Private endpoints address network connectivity, not central management of the search connection credentials/configuration. C. Per agent keys duplicate secret management and do not centralize the configuration. D. Separate search resources increase administration and are unnecessary when all agents use the same search service. Exam tip. Use Foundry project connections to reuse external service configuration across apps and agents in the same project. Proceed to question number 4. We are moving to OpenTelemetry tracing. Contoso Retail sends telemetry from a Foundry agent and a separate LangChain application to one Application Insights resource. The Foundry app is configured with Azure Monitor Telemetry. The LangChain app uses an Azure OpenTelemetry tracer with content recording disabled. For each statement, select Yes if the statement is true. Otherwise, select No. Review Statement 1. The LangChain application emits its agent spans to Application Insights even if the Azure OpenTelemetry tracer is not configured as a callback. Review Statement 2. Assigning different OTL_service_name values to the two applications lets their telemetry be distinguished in the same Application Insights resource. Review Statement 3. With content recording disabled on the LangChain tracer, prompt and tool payload content is still recorded in telemetry. Statement 1. The answer is no. Without the tracer callback, the LangChain service does not emit the intended spans through that instrumentation path. Statement 2. The answer is yes. OTel_service_name sets the OpenTelemetry service identity, allowing telemetry from different services to be separated. Statement 3. The answer is no. Disabling content recording is specifically intended to keep prompt and tool content out of recorded telemetry. In shared application insights, use OpenTelemetry service identity to separate apps and disable content recording when payloads must not be captured. The next item is question number 5. Consider this scenario. A logistics company uses Azure Content Understanding and Foundry tools for shipment paperwork. One pipeline must cheaply process large volumes of independent shipping label PDFs. Another must reconcile several related documents against reference rules using multi-step reasoning. Match each pipeline requirement to the appropriate content understanding task configuration. The source items are as follows. Source 1. High-volume processing of one independent PDF at a time. Source 2. Cross-document reconciliation with reference data and multi-step reasoning. Now review the available destinations. Destination Option A. Multi-file task in standard mode. Destination Option B. Single-file task in Pro mode. Destination Option C. Single-file task in standard mode. Destination Option D. Multi-file task in Pro mode. For Mapping 1, pair high-volume processing of one independent PDF at a time with single-file task in standard mode. For Mapping 2, pair cross-document reconciliation with reference data and multi-step reasoning with multi-file task in Pro mode. The requirement is satisfied because standard mode is optimized for straightforward, cost-effective document processing. Pro mode supports more complex reasoning, including workflows involving multiple inputs and reference information. A useful examination rule is this. Choose standard mode for routine single document extraction. Use Pro mode when the task requires multi-step reasoning across multiple inputs. Proceed to question number 6. Scenario. A Python service named Trip Planner calls a model deployed in a Microsoft Foundry project. The service must authenticate with Microsoft Entra credentials and send a prompt through the Azure OpenAI Responses API obtained from AI Project Client. Complete the two relevant code choices. Review Statement 1. Create the project credential by using the blank. The available choices are 1. Azure Key Credential, Default Azure Credential, or Client Secret Credential without parameters. Review Statement 2. Send the prompt by calling OpenAI_client.responses.the_blank. The available choices are 2. Create, Compact, or Delete. Statement 1 should be completed with Default Azure Credential. Default Azure Credential supports Microsoft Entra authentication and can resolve a managed identity when the app runs in Azure. Statement 2 should be completed with Create. The Responses API creates an inference response with responses.create. The key takeaway is for keyless Foundry Python apps, pair Default Azure Credential with AI Project Client and use the OpenAI Client's responses.create method. Review question number 7. Carefully. This question moves us into Workflow PowerFX. Consider the following scenario. A service desk workflow in Microsoft Foundry asks a user for an escalation code and stores the answer in a local variable named escape code. Complete the PowerFX expressions so the branch runs only when escape code has a value and the next message returns that value in uppercase. For the first statement, use the blank for the if/else condition. Choose between 1. Is blank local.escape code, not is blank local.escape code, or is empty local.escape code. For the second statement, use the blank for the send message expression. Choose between 2. Upper local.escape code, upper escape code, or local.escape code. For statement 1, select not is blank local.escape code. Not is blank dot is true only when the local variable contains a value. For statement 2, select upper local.escape code. Upper local.escape code converts the stored local variable text to uppercase, and the braces evaluate the expression in the message. Remember this distinction for the exam. In Foundry Workflow PowerFX, reference local variables as local, name, combine isBlank with not to test for a supplied value. Let us work through question number 8. Let us first review the situation. A claims support agent accepts user screenshots, stores them as blobs, and passes blob URLs through a tool. Azure AI Content Safety must inspect images during agent execution, block harmful content from progressing or being returned, and read blobs with least privilege. Select the guardrail coverage and storage authorization that satisfy the requirements. Choose the correct entry for every drop-down field. The first statement reads, configure the guardrail to inspect the blank. The options for this statement are 1. Tool calls only, with blocking, user input and output only, with annotation, or user input, output, tool responses, and tool calls, with blocking. The second statement reads, authorize content safety to read the blobs by using the blank. The options for this statement are 2. Storage account access keys, a system-assigned managed identity with storage blob data reader, or a system-assigned managed identity with storage blob data contributor. The correct value for statement 1 is user input, output, tool responses, and tool calls, with blocking. Scanning every agent intervention point prevents harmful image-related content from entering through input/tool paths or leaving through output, and blocking enforces the requirement. The correct value for statement 2 is a system-assigned managed identity with storage blob data reader. Blob data reader grants read-only data access needed to fetch images without broader write permissions or shared keys. Keep this examination point in mind. For agent image moderation, cover every path where content can enter or leave. Grant only blob data reader when the service only needs to fetch blobs. Question number 9. Now, the focus now shifts to agent workflows. A bank uses 3 Foundry agents. 1 classifies service requests, 1 retrieves policy guidance, and 1 can open a case through an API. The process must follow fixed steps, branch on the classifier result, share state, and call the case agent only when required. Which orchestration approach minimizes custom development while meeting these requirements? Options. Option A. Coordinate independent agent runs in custom application code. Option B. Use a multi-agent group chat. Option C. Use a Foundry workflow. Option D. Use unrelated threads and runs with no workflow. The correct answer is option C. Use a Foundry workflow. A workflow provides deterministic step-based orchestration, conditional branching, and shared state while reducing the custom coordination code needed across agents. Now consider why the remaining options are unsuitable. A. Custom coordination can implement the behavior but increases development effort. B. Group chat is conversational and emergent rather than the best fit for deterministic branch and state processing. D. Independent runs do not by themselves provide the required shared state and conditional orchestration. Exam tip. Choose a workflow when agent coordination must be deterministic, stateful, and branch-driven rather than conversational. The next item is question number 10. An accessibility app uses a custom speech-to-text model for the ENUS locale. The model is published through custom speech, and the app sends a REST request that includes a project property. The service reports that the supplied value is not a valid speech project. For the custom speech REST API version that exposes the project property, which identifier should the application supply? Review the options. Option A. The Microsoft Foundry project URL. Option B. The custom speech endpoint URL. Option C. The custom speech project ID. Option D. The Microsoft Foundry project ID. The best answer is option C, the custom speech project ID. This is correct because the project property in the applicable custom speech API refers to the custom speech project resource, so it must contain that project's ID. The incorrect choices fail for the following reasons. A Foundry project URL is not the custom speech project identifier expected by the property. B. The custom endpoint URL identifies the deployed recognition endpoint, not the project. D. A Microsoft Foundry project ID is a different resource identifier. Keep Foundry project IDs, custom speech project IDs, and custom speech endpoint URLs distinct. REST properties are service-specific. Question number 11. Requires careful analysis. Next, we enter the topic of custom speech lifecycle. Analyze the scenario before evaluating the choices. A call center application performs real-time recognition through a custom speech endpoint. The custom speech-to-text model deployed to that endpoint reaches its expiration date before the team retrains it. What behavior should the team expect for real-time recognition requests after the custom model expires? Evaluate each option against the stated requirement. Consider option A. The service falls back to the most recent base model for the same locale. Consider option B. All recognition requests return a 4xx response until another custom model is deployed. Consider option C. The expired custom model continues indefinitely until it is manually deleted. Consider option D. The entire custom endpoint is deleted automatically. The required response is option A. The service falls back to the most recent base model for the same locale. The key reason is for real-time speech recognition. An endpoint whose custom model expires can fall back to the latest base model for the same locale rather than continuing to use the expired model. The other choices do not satisfy the requirement because B. That failure behavior is not the expected real-time endpoint fallback behavior. C. Expired custom models are not intended to remain the active recognition model indefinitely. D. Model expiration does not mean the endpoint itself is automatically deleted. A useful examination rule is this. Custom speech model expiration and endpoint deletion are different lifecycle events. Real-time endpoints can fall back to the current base model. Now consider question number 12. Review the situation. Developers call a model deployment through the Azure OpenAI v1 API by using default Azure credential. They can sign in with Azure CLI, but inference returns HTTP 403. They need only the permission required to invoke Azure OpenAI models. Which BAC role should you assign? Available choices. Choice A, contributor. Choice B, cognitive services data reader. Choice C, cognitive services OpenAI user. Choice D, cognitive services user. The appropriate choice is option C, cognitive services OpenAI user. Here is the technical justification. Cognitive Services OpenAI user grants the data plane permissions required for Azure OpenAI inference while avoiding broader management permissions. The remaining options are incorrect because A. Contributor is a management plane role and is broader than necessary for inference. B. Data reader is intended for reading service data/metadata and does not provide the required Azure OpenAI inference permission. D. Cognitive Services user is broader/generic and is not the least privileged Azure OpenAI v1 inference role when OpenAI user is available. The key takeaway is for Azure OpenAI keyless inference. Use an Azure OpenAI data plane role, such as Cognitive Services OpenAI user rather than contributor. Let us examine question number 13. Next, we enter the topic of MCP tool choice. Review the scenario carefully. A Foundry agent has several tool types, including an MCP tool that queries an internal standards repository. A Python application uses the agent's runs create__process method, and every run in this path must select the MCP tool type rather than allowing the model to answer directly or choose another tool. Which tool_choice value should the run specify? Compare the following options. Option A is tool_choice equals auto. Option B is tool_choice equals type::MCP. Option C is tool_choice equals required. Option D is tool_choice equals type::knowledge_base. The required response is option B, tool underscore choice equals type colon MCP. The reasoning is as follows. A named tool choice with type MCP constrains the run to the MCP tool type. This is more specific than required, which only mandates that some available tool be called. A. Auto lets the model decide whether and which tool to call. C. Required guarantees at least one tool call, but does not select the MCP tool type when other tools are available. D. Knowledge underscore base is not the MCP named tool type required by the scenario. Remember this distinction for the exam. Use required to mandate some tool call. Use a named/specific tool choice when the run must select a particular tool type. Question number 14. Consider this scenario. An HR knowledge agent was updated. Reviewers find that some answers contain claims not supported by retrieved policy documents, while a smaller set of answers trigger responsible AI policy flags. Match each issue to the observability signal that directly evaluates it. Begin with the following source items. The first source item is claims are not supported by retrieved documents. The second source item is responses trigger policy violations. Match the source items to these destinations. Destination A, token usage analytics. Destination B, risk and safety metrics. Destination C, latency breakdown traces. Destination D, groundedness evaluation metrics. Map claims are not supported by retrieved documents to groundedness evaluation metrics. Map responses trigger policy violations to risk and safety metrics. The requirement is satisfied because groundedness measures whether responses are supported by supplied context. Risk and safety metrics evaluate harmful or policy-violating content. Keep this examination point in mind. Use groundedness for evidence support, safety metrics for policy risk, traces for execution timing, and token analytics for consumption. Question number 15. This question moves us into OpenAPI authentication. A Foundry agent uses an OpenAPI 3.0 tool to call a shipping rate service. The service expects a secret value in the XAPI key header, and the secret is stored in a Foundry project connection. What should the OpenAPI specification define so the connection's key can be supplied using the service's required authentication pattern? Option A, a bearer token security scheme. Option B, an API key security scheme for the required header. Option C, an ordinary header parameter repeated on every operation. Option D, an Azure Key Vault resource declaration. In this case, select option B, an API key security scheme for the required header. An OpenAPI API key security scheme declares header-based API key authentication, allowing the tool's connection-based authentication to inject the key consistently. The alternatives can be eliminated because A, bearer authentication uses an authorization bearer token, not the service's API key header pattern. C, a normal header parameter describes request data but does not model authentication as an OpenAPI security scheme. D, Key Vault is a secret store, not an OpenAPI authentication scheme. Exam tip. For OpenAPI tools, describe API key auth under components.security schemes and apply the scheme through the OpenAPI security configuration. The next key item is question number 16. This scenario establishes the key requirement. An online learning assistant receives many short factual questions and a smaller number of complex planning prompts. The team wants inexpensive, low-latency handling for simple requests while automatically using a more capable model when reasoning demands it. Which Foundry approach best meets the requirement? Focus on the distinction between these options. Option A, send every request to the largest available model. Option B, increase max output tokens on every request. Option C, use a model router that selects among underlying models based on the request. Option D, send every request to the smallest model. The correct answer is option C. Use a model router that selects among underlying models based on the request. This is correct because a model router can direct straightforward requests to faster/lower cost models and escalate more complex prompts to higher capability models, balancing cost, latency, and quality. Now consider why the remaining options are unsuitable. A, always using the largest model preserves capability but wastes cost and latency on simple requests. B, a larger token limit does not select an appropriate model or reduce common query cost. D, always using the smallest model can degrade quality on complex reasoning tasks. Use model routing when workload complexity varies and you need dynamic cost/latency/quality trade-offs across models. Apply precise reasoning to question number 17. We are moving to token analytics. Identify the decisive requirement in this scenario. A high-traffic research agent shows a sharp cost increase after a release, but request count is unchanged. The team needs to determine whether prompts became larger, completions became longer, or model/tool interactions expanded token consumption. Which observability capability should you inspect first? Eliminate any option that fails a requirement. Next, option A, run success rate. Next, option B, token usage. Next, option C, groundedness evaluation. Next, option D, latency. The best answer is option B, token usage. The key reason is token usage exposes input and output token consumption associated with runs, making it the direct signal for diagnosing cost increases caused by larger prompts or responses and expanded model interactions. The incorrect choices fail for the following reasons. A. Success rate shows reliability, not how much model input/output was consumed. C. Groundedness measures response support by context, not token-driven cost. D. Latency shows duration and bottlenecks, but does not directly identify input/output token growth. A useful examination rule is this. When traffic is stable but model cost changes, compare prompt/input and completion/output token usage before investigating unrelated quality metrics. Question number 18 highlights an important distinction. Focus on the following situation. A compliance agent retrieves internal records before composing every answer and also invokes an audited business API. The agent will be published. Retrieval must occur on every run, and tool calls must use the published agent's own isolated identity rather than shared project credentials. Complete the two configurations. Statement 1. Set tool_choice to the blank, so each run must invoke at least one tool. The available choices are 1. Auto, none, or required. Statement 2. Configure tool authentication to use the blank. The available choices are 2. API keys embedded in prompts, the shared project agent identity, or the published agent's distinct Microsoft intra-agent identity. For statement 1, select required. Required prevents a direct model-only response by requiring one or more tool calls. For statement 2, select the published agent's distinct Microsoft intra-agent identity. A published agent can use its own distinct identity, allowing permissions and audit trails to be isolated from shared project resources. The key takeaway is use tool_choice equals required for mandatory tool use. Assign least privileged tool permissions to the published agent's own identity when isolation is required. The next item is question number 19. The focus now shifts to OpenAPI project connection. Review the situation. A Foundry project has an OpenAPI tool for a supplier API and a project connection named Supplier API Auth that stores the API key. The OpenAPI document already defines the appropriate API key security scheme, but traces show no key is being sent and the API returns 401. What should you configure? Available choices. Option A. Enable caller identity pass-through. Option B. Bind the OpenAPI tool authentication to the Supplier API Auth project connection. Option C. Add the secret value directly to every operation in the OpenAPI document. Option D. Replace the project connection with the project's default model connection. In this case, select Option B. Bind the OpenAPI tool authentication to the Supplier API Auth project connection. Here is the technical justification. The OpenAPI tool must be associated with the project connection that holds the external API credential so the declared security scheme can obtain and send the key. The other choices do not satisfy the requirement because A. Identity pass-through sends the caller's intra-identity and does not supply the external API key. C. Embedding secret values in the OpenAPI document defeats centralized secret handling and is not required. D. A model/default connection is unrelated to the external API credential. Remember this distinction for the exam. An OpenAPI security scheme describes how authentication is sent. The tool's project connection supplies the actual credential. Let us focus on question number 20. The central scenario is as follows. A legal support agent calls an internal precedent API before generating answers. Some runs are slow, and others produce incorrect answers even though the API returned correct data. Engineers need the ordered sequence of model calls, tool calls, timing, and errors for individual runs. Which observability capability should they use? The relevant choices are as follows. Now examine choice A, safety metrics. Now examine choice B, tracing. Now examine choice C, token usage. Now examine choice D, aggregate monitoring only. The appropriate choice is option B, tracing. The reasoning is as follows. Tracing records the run's execution path, including model operations, tool invocations, timing/latency, and exceptions, which is needed to diagnose individual agent executions. The remaining options are incorrect because A. Safety metrics evaluate risk and policy behavior, not the ordered execution path. C. Token usage quantifies model consumption, but does not reconstruct tool/model sequencing. D. Aggregate monitoring can show trends, but lacks the per-run span sequence needed for root cause analysis. Keep this examination point in mind. Use traces for per-run causality and timing. Use dashboards/metrics for aggregate trends. Proceed to question number 21. Scenario. A museum assistant accepts visitor-uploaded images and uses text extracted from those images as model context. The service must both block unsafe visual content and prevent hidden instructions in image-derived text from manipulating the model. The team proposes enabling prompt shields only for direct user prompts. Does this single control meet the complete requirement? The options are choice A, no. Choice B, yes. The required response is option A, no. The requirement is satisfied because no. A user prompt shield targets direct prompt attacks, but by itself it neither moderates unsafe image content nor covers the indirect instructions embedded in image-derived context required by the scenario. B. The requirement has two independent risks. Direct user prompt shielding alone does not mitigate both. Exam tip. Multimodal safety often needs separate controls for harmful visual content and indirect prompt injection in retrieved/extracted context. We will now analyze question number 22. Begin by examining the scenario. A museum assistant accepts visitor-uploaded images and uses text extracted from those images as model context. The service must both block unsafe visual content and prevent hidden instructions in image-derived text from manipulating the model. The team proposes image moderation that blocks unsafe images before they are processed. Does this single control meet the complete requirement? Choose from the following options. Option A is yes. Option B is no. The best answer is option B, no. No. Image moderation addresses harmful visual content, but it does not by itself detect indirect prompt injection instructions hidden in image text. The alternatives can be eliminated because A. Blocking unsafe images handles only one of the two required threat classes. Indirect prompt injection still needs a prompt shield control. Image content moderation classifies visual harm. Prompt shields address adversarial instructions. Do not treat them as interchangeable. Now consider question number 23. The difficulty level here is medium. Consider this scenario. A museum assistant accepts visitor-uploaded images and uses text extracted from those images as model context. The service must both block unsafe visual content and prevent hidden instructions in image-derived text from manipulating the model. The team proposes using prompt shields for document/indirect attacks on the extracted image text. Does this single control meet the complete requirement? Review the options. Choice A, no. Choice B, yes. The correct answer is option A, no. This is correct because no. Document/indirect prompt shields can detect malicious instructions in external context, including image-derived text, but they do not replace image moderation for unsafe visual content. Now consider why the remaining options are unsuitable. B. The shield addresses the injection risk, but not the separate requirement to block unsafe images. A useful examination rule is this. Prompt shields for documents mitigate indirect injection. Pair them with image moderation when harmful visual content must also be blocked. Question number 24 highlights an important distinction. The central scenario is as follows. A museum assistant accepts visitor-uploaded images and uses text extracted from those images as model context. The service must both block unsafe visual content and prevent hidden instructions in image-derived text from manipulating the model. The team proposes protected material detection as the only control. Does this single control meet the complete requirement? The relevant choices are as follows. Option A, yes. Option B, no. The appropriate choice is option B, no. The key reason is no. Protected material detection is intended to identify protected/copyright-related content. It does not provide the required unsafe image moderation and indirect prompt injection defense. The incorrect choices fail for the following reasons. A. Protected material detection targets a different risk class and cannot satisfy either required control set by itself. The key takeaway is map each guardrail to its risk. Protected material, harmful content, PI, and prompt injection are separate control categories. Now consider question number 25. This question moves us into our AG evaluation. Background. Woodgrove Health is building a staff support agent in Microsoft Foundry. The agent answers natural language questions from approved clinical procedure PDFs indexed for retrieval. Current environment. The agent retrieves relevant passages and then generates a grounded response. The validation team must assess final answer quality before deployment. Business requirements. Staff should receive answers that directly address their questions and do not omit important information. Technical requirements. Evaluation must assess whether responses are relevant, supported by retrieved context, and complete rather than measuring only one of those dimensions. Which evaluation approach should you include? Option A. Fine-tune the base model before every evaluation run. Option B. Use only a groundedness evaluator. Option C. Configure a or AG evaluation set that includes relevance, groundedness, and response completeness measures. Option D. Use only a custom blocking guardrail. In this case, select Option C. Configure a or AG evaluation set that includes relevance, groundedness, and response completeness measures. Here is the technical justification. Our AG system evaluation uses complementary evaluators. Relevance measures how accurately the response addresses the query, groundedness checks support by context, and response completeness checks whether critical expected information is missing. The other choices do not satisfy the requirement because A. Fine-tuning changes model behavior. It is not an evaluation method for the stated response quality dimensions. B. Groundedness alone checks support by context, but does not fully assess direct relevance and completeness. D. A blocking guardrail enforces policy/risk controls rather than measuring our AG answer quality. Remember this distinction for the exam. For our AG quality, combine evaluators by dimension. Retrieval quality, groundedness, relevance, and completeness are not interchangeable. Question number 26. Background. Tailspin Toys uses a Foundry customer support agent that answers questions about its own product catalog. Current environment. The agent has a capable base model and can access product data. Users sometimes ask unrelated general knowledge questions. Business requirements. The agent must restrict its conversational scope to products sold by Tailspin Toys. Technical requirements. The team wants the simplest configuration change that constrains the agent's role without changing the model or adding retrieval examples. What should you configure? Available choices. Choice A. Increase the temperature parameter. Choice B. Modify the agent's system instructions to restrict its allowed scope. Choice C. Increase top P sampling. Choice D. Add unrelated few-shot examples. The required response is Option B. Modify the agent's system instructions to restrict its allowed scope. The reasoning is as follows. System instructions define the agent's role, boundaries, and expected behavior, making them the direct control for restricting answers to the approved product domain. The remaining options are incorrect because A. Higher temperature increases variability and does not enforce topical scope. C. Top P changes sampling behavior, not the agent's allowed subject matter. D. Few-shot examples can demonstrate style or task patterns, but are less direct than explicit scope instructions, and the proposed examples are unrelated. Keep this examination point in mind. Use system/agent instructions for role and scope constraints. Use temperature/top P for sampling behavior. Review question number 27 carefully. Next, We enter the topic of model selection. Consider the following scenario. A research assistance agent must generate detailed natural language answers grounded in Azure AI search. Queries can require multi-step reasoning across long retrieved contexts, and high response quality is more important than minimizing model size. Which model type is the best fit? Review each available choice. Choice A key phrase extraction model. Choice B, a large language model, LLM. Choice C, a small language model, SLM, chosen only for minimum compute. Choice D, an image-only multimodal model. The best answer is option B, a large language model, LLM. The requirement is satisfied because an LLM is suited to detailed generation, long context synthesis, and complex multi-step reasoning over retrieved grounding content. A. Key phrase extraction is a narrow text analysis task and does not generate detailed reasoned answers. C. An SLM may reduce cost/latency, but is not the best fit when deep reasoning and long context quality are decisive. D. An image-only focus does not match a text-grounded Azure AI search reasoning workload. Exam tip. Select models by required capability. Long context reasoning and rich generation favor an LLM. Do not choose smaller models solely for cost when quality is decisive. Let us focus on question number 28. Focus on the following situation. A ticket routing agent sometimes answers directly even though each execution must call at least one attached tool. You are completing the run payload used by the application. Match each missing payload element to the correct value. Review the available source items. Source item 1. Property that controls whether and how the model selects tools. Source item 2. Value that requires one or more tool calls. The destination requirements are as follows. Target A, response_format. Target B, required. Target C, tools. Target D, auto. Target E, tool_choice. Target F, type. The first mapping connects property that controls whether and how the model selects tools to tool_choice. The second mapping connects value that requires one or more tool calls to required. Tool_choice controls tool call selection behavior. Setting it to required prevents the model from completing the run without making at least one tool call. Tool_choice equals auto permits direct answers. Tool_choice equals required mandates at least one tool invocation. Let us examine question number 29. The focus now shifts to search connection reuse. Let us first review the situation. Several internal web apps use the same Microsoft Foundry project and must retrieve documents from one Azure AI search service before model inference. Key-based authentication is prohibited. The search configuration should be shared, and administrators want to avoid repeating endpoints and auth settings in every app. What should you configure? Compare the following options. Option A is a reusable Azure AI search project connection in Foundry and reference it from each application. Option B is a separate hard-coded search endpoint and credential configuration in every application. Option C is a different Azure AI search service for each application. Option D is a custom HTTP connection that stores a search key for each application. The correct answer is option A reusable Azure AI search project connection in Foundry and reference it from each application. This is correct because a project-level Azure AI search connection centralizes the reusable search configuration and can use Microsoft Intra/keyless authentication, reducing duplicated administration. The alternatives can be eliminated because B, direct per-app configuration duplicates administration even if intra-authentication is used. C, separate search services are unnecessary and increase operational overhead. D, storing search keys conflicts with the requirement to prevent key-based authentication. A useful examination rule is this. Use Foundry project connections to centralize reusable service configuration. Choose intra/managed identity when key-based auth is disallowed. Proceed to question number 30. A procurement analysis agent needs 3 additional capabilities. Execute calculations during a conversation, obtain current information from public websites, and search documents that users upload directly to the agent. Match each requirement to the appropriate Foundry agent tool. The items to be placed are: the first source item is run calculations during the conversation. The second source item is retrieve current information from public websites. The third source item is search documents uploaded directly to the agent. The target positions are Destination A, File Search. Destination B, Microsoft Fabric. Destination C, Grounding with Bing Search. Destination D, Computer Use. Destination E, Code Interpreter. The correct destination for run calculations during the conversation is Code Interpreter. The correct destination for retrieve current information from public websites is Grounding with Bing Search. The correct destination for search documents uploaded directly to the agent is File Search. The key reason is Code Interpreter executes computational code. Bing Grounding retrieves current public web information, and File Search indexes / retrieves content from files attached for agent use. The key takeaway is map tools to data / action type. Code Interpreter computes. Bing grounds on the public web, and File Search retrieves uploaded document content. The next item is question number 31. We are moving to end-to-end tracing. Consider this scenario. A Python-hosted customer support service invokes a Foundry prompt agent outside the Foundry portal. Engineers need end-to-end tracing for agent runs, including latency breakdowns and exceptions, with standard telemetry instrumentation and an Azure telemetry backend. Which two components should you use? Select 2. Identify all valid responses. The options are Option A, Microsoft Sentinel. Option B, OpenTelemetry. Option C, Azure Monitor Agent. Option D, Application Insights. Option E, a log analytics workspace by itself. Select Option B, OpenTelemetry, and Option D, Application Insights. Here is the technical justification. OpenTelemetry provides vendor-neutral application instrumentation and span propagation, while Application Insights is the Azure Monitor backend used to collect and analyze the resulting application traces. Now consider why the remaining options are unsuitable. A. Microsoft Sentinel is a SIEM/source service, not the application tracing instrumentation / backend pair requested. C. Azure Monitor Agent collects machine/host telemetry and is not the primary SDK instrumentation component for agent application traces. E. A log analytics workspace alone does not provide the end-to-end application tracing instrumentation required by the scenario. Remember this distinction for the exam. For Foundry app, tracing outside the portal, instrument with OpenTelemetry and export traces to Application Insights. Question number 32. Scenario. A field service assistant in Microsoft Foundry helps technicians troubleshoot equipment. A technician may reopen the same repair case several days later. The assistant must continue from the complete prior interaction, including messages, tool invocations, and tool results. How should the application preserve and automatically reuse the complete interaction history for that repair case? Review the options. Option A. Store only the assistant's final reply and prepend it to the next prompt. Option B. Create a conversation, persist its conversation ID, and reuse that ID on later requests for the same case. Option C. Enable an agent-level summary setting and rely on the summary as the complete historical record. In this case, select Option B. Create a conversation, persist its conversation ID, and reuse that ID on later requests for the same case. The reasoning is as follows. A Foundry conversation is the durable container for interaction items. Reusing its ID lets subsequent responses use the stored messages, tool calls, tool outputs, and other conversation items as context. The incorrect choices fail for the following reasons. A. Saving only the last assistant reply discards earlier user messages, tool calls, tool outputs, and other context. C. Long-term memory or summaries are not a substitute for the complete conversation item history required by the scenario. Keep this examination point in mind. Use a Foundry conversation for durable full interaction history. Use memory for distilled knowledge that must persist across sessions. The next item is question number 33. The focus now shifts to Claude generation controls. Review the situation. A release note service uses a Claude deployment in Microsoft Foundry through the Anthropic Messages API. Automated tests compare generated summaries with approved wording patterns. The team wants less wording variation while keeping strong reasoning effort. Complete the request settings. The first statement reads, set temperature to the blank to minimize sampling variability. Choose between 1, 0, 0.5, or 1.0. The second statement reads, set output_config effort to the blank to maximize reasoning effort among the available choices. Choose between 2. Low, medium, or high. Statement 1 should be completed with 0. Temperature 0 is the least variable choice in the row and best matches deterministic validation. Statement 2 should be completed with high. High is the strongest reasoning effort choice provided in the row. Exam tip. For Claude and Foundry, temperature controls sampling variability. Output_config. Effort controls reasoning effort when the deployed model supports it. Now consider question number 34. A legal research chat application uses an Azure AI search index that stores vectorized internal guidance. Complex questions often span several passages, and earlier turns in the conversation should influence how later searches are planned. Search latency should be reduced by executing independent subqueries concurrently. Which retrieval pattern best satisfies these requirements? Choice A, Classic Retrieval Augmented Generation, RAG. Choice B, Iterative Retrieval implemented as one sequential query at a time. Choice C, Agentic Retrieval for Retrieval Augmented Generation, RAG. Choice D, Chain of Thought Prompting without changing retrieval. The appropriate choice is option C, Agentic Retrieval for Retrieval Augmented Generation, RAG. The requirement is satisfied because agentic retrieval can use conversation history to plan multiple focus subqueries, execute them in parallel, and combine the best results for grounding. The other choices do not satisfy the requirement because A, Classic RAG normally sends a single search query and does not provide the same built-in multi-query planning from chat history. B, Sequential iterative retrieval does not meet the explicit parallel execution requirement. D, Reasoning prompts do not by themselves decompose and execute Azure AI search retrieval queries. Choose agentic retrieval when you need LLM-based query planning, conversation-aware decomposition, and parallel subqueries. Let us work through question number 35. Review the scenario carefully. A travel planning agent in Microsoft Foundry must remember a user's stable preferences, such as preferred airline and accessibility needs, even after a new conversation starts. During any individual chat, the user must also be able to upload itinerary PDFs for grounding. Select the Foundry capability for each requirement. Complete each statement by selecting the appropriate value. For the first statement, for durable preferences across separate conversations, use the blank. Select from 1. Conversation history, agent memory backed by persistent storage, or orchestration managed session context. For the second statement, for grounding on files uploaded by the user during a chat, use the blank. Select from 2. Code Interpreter Tool, File Search Tool, or Azure AI Search Tool configured only for a fixed enterprise index. The answer to the first statement is agent memory backed by persistent storage. Persistent agent memory carries distilled user knowledge across conversations. Conversation/session context is short-lived. The answer to the second statement is File Search Tool. File Search is the purpose-built agent tool for user-provided documents that need retrieval during the interaction. A useful examination rule is this. Use memory for durable user-specific knowledge across sessions, and File Search for grounding on documents supplied to the agent. Proceed to question number 36. Review the situation. A compliance assistant in Microsoft Foundry summarizes retrieved operating procedures. Some generated answers omit mandatory checklist items, even though those items are present in the retrieve context. The application must detect the omission and correct it before returning the response. What should you add to the application logic? Review the options. Option A, replace the current deployment with a smaller model. Option B, run a completeness evaluation and retry or regenerate when the response fails the check. Option C, decrease max_tokens so the response is more concise. Option D, replace the existing grounded design with RAG. The best answer is option B, run a completeness evaluation and retry or regenerate when the response fails the check. A pre-return evaluator can check the generated response for required content and trigger a retry or regeneration when completeness criteria are not met. The remaining options are incorrect because A, a smaller model does not directly enforce the required completeness condition. C, reducing the output budget can increase the chance that required information is omitted. D, the scenario already retrieves the needed content, Changing to our AG does not address the post-generation omission. The key takeaway is when retrieved evidence is present but generation misses required content, evaluate the output and retry before returning it. Let us examine question number 37. This question moves us into rate limit handling. Begin by examining the scenario. A reservation agent in Microsoft Foundry calls a deployed Azure OpenAI model. During peak load, some requests receive HTTP 429 responses even though the application stays within its configured workload design. Which client behavior should you implement to improve reliability when throttling occurs? Choose from the following options. Choice A. Retry immediately in a new conversation with no delay. Choice B. Use exponential backoff with jitter for retries. Choice C. Remove registered agent tools before each retry. Choice D. Split every uploaded document into smaller files. The required response is option B. Use exponential backoff with jitter for retries. This is correct because HTTP 429 indicates throttling. Exponential backoff with jitter reduces synchronized retry pressure and gives capacity time to recover while respecting service limits. A. Immediate retries can amplify throttling and create a retry storm. C. Tool count is unrelated to model rate limit recovery unless tool registration itself is the documented bottleneck. D. File size does not address a rate limit response from the model endpoint. Remember this distinction for the exam. Treat 429 as throttling. Respect retry guidance and use exponential backoff, preferably with jitter. Let us work through question number 38. Let us first review the situation. A team evaluates a Microsoft Foundry agent from a GitHub Actions workflow whenever a pull request is opened. Azure authentication must avoid long-lived credentials. If quality scores fall below the acceptance threshold, the evaluation job must report failure so the repository can treat the required check as unsuccessful. Complete the workflow design. Review Statement 1. Authenticate the workflow to Azure by using the blank. The options for this statement are 1. A personal access token stored as a secret, Azure login with OpenID Connect, OIDC, or a manually copied user access token. Review Statement 2. When evaluation thresholds are not satisfied, configure the evaluation job to the blank. The options for this statement are 2. Send only a notification, fail, or lock the target branch directly. The correct value for Statement 1 is Azure login with OpenID Connect, OIDC. Azure login with OIDC is the secure short-lived authentication pattern for GitHub Actions. The correct value for Statement 2 is fail. The workflow must fail the evaluation check when thresholds are missed. Alerts alone do not create a failed required check. Keep this examination point in mind. Use OIDC for secretless GitHub to Azure authentication, and fail the quality gate so branch protection can enforce the result. Question number 39. Consider this scenario. A policy assistant generates answers from retrieved governance documents. Users have reported that some responses omit mandatory clauses even when those clauses exist in the retrieved evidence. Proposed solution. Increase the response max_tokens value. Does the proposed solution meet the goal of improving the completeness of the response returned to the user? Choice A. Yes. Choice B. No. The correct answer is option B. No. The key reason is increasing max_tokens only raises the possible output budget. Without evidence that responses are being truncated, it does not ensure that the model includes every required clause. The alternatives can be eliminated because A larger token budget can help only when output length is the limiting factor. It does not by itself validate or enforce completeness. Exam tip. Token limits control available output length, not whether every required fact is selected. Use evaluation or reflection to enforce completeness. Evaluate question number 40. Against every requirement. This question focuses on completeness controls. Pay close attention to every stated constraint. A policy assistant generates answers from retrieved governance documents. Users have reported that some responses omit mandatory clauses even when those clauses exist in the retrieved evidence. Proposed solution. Add a reflection pass that checks for missing mandatory clauses and regenerates the answer when necessary. Does the proposed solution meet the goal of improving the completeness of the response returned to the user? Compare every choice before deciding. Next, option A. Yes. Next, option B. No. In this case, select option A. Yes. Here is the technical justification. A reflection pass explicitly checks the draft against the completeness requirement and regenerates when required clauses are missing, so it directly addresses the failure. Now consider why the remaining options are unsuitable. B. The proposed reflection and regeneration loop directly tests the missing clause condition, so rejecting it would ignore the stated corrective logic. Reflection is useful when the model must inspect its draft against explicit criteria and regenerate before the answer is returned. We will now analyze question number 41. Begin by examining the scenario. A policy assistant generates answers from retrieved governance documents. Users have reported that some responses omit mandatory clauses even when those clauses exist in the retrieved evidence. Proposed solution: increase the temperature value to make generation more varied. Does the proposed solution meet the goal of improving the completeness of the response returned to the user? Now examine the possible answers. Option A is yes. Option B is no. The best answer is option B, no. The reasoning is as follows. Higher temperature increases sampling variability. It does not enforce inclusion of required clauses and can make outputs less predictable. The incorrect choices fail for the following reasons. A. More randomness is not a completeness control and can increase wording and content variation. A useful examination rule is this. Temperature adjusts randomness. Do not use it as a substitute for factual, grounding, or completeness validation. Review question number 42. Carefully. Consider the following scenario. A policy assistant generates answers from retrieved governance documents. Users have reported that some responses omit mandatory clauses even when those clauses exist in the retrieved evidence. Proposed solution: run a completeness evaluation and block any response that scores below the required threshold. Does the proposed solution meet the goal of improving the completeness of the response returned to the user? Review each available choice. Choice A, yes. Choice B, no. The appropriate choice is option A. Yes. The requirement is satisfied because a completeness evaluator used as a gate prevents responses that fail the defined completeness threshold from being returned, satisfying the stated delivered response quality goal. The other choices do not satisfy the requirement because B. The proposed evaluator directly measures the required quality dimension and blocks outputs that do not meet the threshold. The key takeaway is evaluation gates can enforce a minimum quality threshold. Use retry/regeneration when the application must also produce a replacement answer. Apply precise reasoning to question number 43. Pay close attention to every stated constraint. A design application in Microsoft Foundry edits interior photographs. Users need to remove a selected object from a room while keeping lighting, perspective, and all unselected regions as close as possible to the source image. The workflow must use the platform's built-in image editing capability. How should the edit request be configured? Compare every choice before deciding. Consider option A. Generate a completely new image from a text-only prompt. Consider option B. Submit the source image together with a mask that identifies the region to edit and request an in-painting style image edit. Consider option C. Create an image variation from the source without identifying a region. Consider option D. Use image-to-image generation with a high transformation strength across the entire image. The correct answer is option B. Submit the source image together with a mask that identifies the region to edit and request an in-painting style image edit. A mask-based image edit constrains the modification to the indicated region while using the source image to preserve the surrounding visual context. The remaining options are incorrect because A. Text-to-image regeneration does not preserve the unmasked source pixels or localize the change. C. An unmasked variation can change content outside the target object. D. A high-strength whole image transformation can alter lighting, style, and regions that should remain unchanged. Remember this distinction for the exam. Exam questions that require changing only a selected image region point to an image edit request with the original image plus a mask. Proceed to question number 44. Scenario. A tourism team generated a promotional image in Microsoft Foundry. After review, the team notices an unapproved brand mark on one small storefront sign. Every other part of the image must remain unchanged. What is the most appropriate correction? Available choices. Choice A. Regenerate the full image with a different random seed. Choice B. Increase prompt guidance and generate a new image. Choice C. Apply a mask-based image edit only over the unwanted brand mark. Choice D. Remove brand names from the original prompt and rerun the entire generation. The required response is option C. Apply a mask-based image edit only over the unwanted brand mark. This is correct because mask-based in painting is designed for localized image edits, so the unwanted mark can be replaced without intentionally regenerating the rest of the composition. A. Changing the seed produces a new overall image rather than a localized correction. B. Guidance strength affects prompt adherence but does not isolate a small edit region. D. Changing the prompt and regenerating can alter the entire image and does not guarantee preservation of the approved content. Keep this examination point in mind. For a surgical correction to an existing image, use a mask. Prompt-only regeneration is a whole image operation. You have completed Set 1 of the AI-103 Microsoft Certified AI Engineer Associate Practice Question Series. How did you score? Share your result in the comments. Work through all the sets to build broader exam readiness and cover more practice questions. Please like this video, subscribe to Tech with Koushik, and enable notifications for more certification exam preparation content. Thank you for watching, and I will see you in another practice set.